Hey guys, so this example is going to talk about example 2 from page 5 of our quadratic graphing packet. So we're going to look through each of these key values, we're going to graph it and talk a little bit about what you need to do for each of these problems. So all of these problems that we've been working on so far have been in this form, y equals a x minus h plus k, where h is your vertical movement of the vertex, opposite of course, and k is your vertical movement of your vertex. So that's actually the first thing we need to set up here, is to find our vertex. We're actually really just going to look at the +1 and the +3. And so like I previously just mentioned, the x value of the vertex is just the opposite of that +1. And so that's going to be -1. And the y value is just simply going to be the k value, which in this case will be 3. Now, as I've probably mentioned in class, the axis of symmetry is just going to be the x value of the vertex, but easier way is to wait and graph, and then you'll recognize what the axis of symmetry should look like. Likewise, your symmetric point, I would also say let's wait until we have points plotted until we do that. So the next stage that we're going to do is we have to find the y-intercept, okay? And so once again, our equation that we're doing here is y equals negative x plus 1 quantity squared plus 3. So to find the y-intercept, remember that we're going to set x equal to 0. The y value is going to be as a result of x equaling 0 here. So we plug this in, and so I would have y equals negative, and then in the place of x, I'm going to put a 0 in. Okay? Plus 1, quantity squared, plus 3. And so, yes, you could plug this into your calculator, being sure to make sure all parentheses and negative signs are taken care of. But by doing this by hand, what I'm really going to end up with is 0 plus 1, which is 1, and 1 squared, which is 1. But take note of something here. There's a negative sign in front of this parentheses. And so when I actually go ahead and do this, let me write it out the long way. I'm squaring the 1, not the negative. But then once I square it, I have to apply the negative sign to it, because this is really like putting a -1 in front of it. So 1 squared is indeed 1, but -1 times 1 is -1. And so my y-intercept here is actually going to be a 2. 0, 2 to be precise. So once we have that, let's write that down on our paper. 0, 2. So next we're going to look at the x-intercept. And so to find the x-intercept, we're going to do the same thing. We're going to look at our equation, and we have to plug a 0 in. But because we're looking for x-intercepts this time we're going to look at setting y equal to 0. So now that I have y equal to 0, we're going to plug that in and talk about how we solve it. So I'm going to put a 0 in for my y, and then the remaining equation stays the same. X plus 1, quantity squared, plus a 3. Again, the idea is to get the x by itself, but even more in general, when solving in vertex form, all of these equations will be able to be solved by isolating square roots. So we'll be able to solve this by isolating the square root, which means I need to get this term in parentheses by itself. And so I need to do everything in my power to do that. So the obvious choice to start with is to get rid of this +3, which means I'm just going to subtract the 3 from both sides. This will be -3 equals, there's still a negative sign in front here that we cannot forget about. So I'm going to rewrite my problem as such. So now that I have that, once again, the goal here is that we're trying to get this parenthesis term that's being squared by itself. Well, like I mentioned about the y-intercept, this negative really is a coefficient or a number of -1 being multiplied to this. And so really what I need to do is I need to get rid of this -1. And the way I'm going to do that is through division. And that's how I'm going to get this by itself. So if there was ever a number in front of this parenthesis, you're going to want to get rid of it through division. If there's no number there or no sign there, well then you just proceed on to taking the square root. But in my case, I have to do this first. So 3 is going to equal, now I have x plus 1 quantity squared, and that's all by itself finally. This now takes me to the part where I can take the square root. I have isolated the square root, which means now I can solve by taking the square root. So I take the square root of both sides. The right side now just becomes x plus 1 because the square root and the squared term cancel each other out. The square root of 3 cannot be simplified. We also need to write it as plus or minus because when you square root 3, it could be a positive or a negative on the outside, and you're still going to get 3 as your solution. So really, what we need to do is write this out as two separate equations. Square root of 3 equals x plus 1, and the negative square root of 3 equals x plus 1. There are my two equations that I have now to solve this with. We're going to get x by itself by subtracting 1 from both sides. And so in my first example, I get root 3 minus 1 equals x. Notice that the 1 is outside of the square root. And here I subtract 1 as well. I'm going to get, and actually we should write the number in front so you don't make that mistake. So keep that in mind. I'm actually going to go ahead and do it that way. So this is not wrong, but I would rather you write the number in front so that you don't make the accidental mistake of assuming the 1's inside the radical. Now, because I'm going to have to plot this on a graph, I really should just go ahead and get approximate answers for these as decimals. So this is where I bring in the calculator. So my first answer, if you can see that on there, is going to be -1 plus the square root of 3. And so I'm going to get approximately 0.7, 0.7 as my x. And then for the other one, move that over, I'm going to do -1 minus the square root of 3. And in this case, I get about negative 2.7. So negative 2.7 is equal to my x. So these are my two x-intercepts. And again, I have to write these as ordered pairs. So technically, what I'm going to transfer back to my worksheet is going to be 0.7 comma 0 and negative 2.7 comma 0. And so those are going to get transferred onto my paper. And here's what we end up with. Okay, so the work has been done for vertex, y-intercept, x-intercept. At this point, I want to go ahead and plot and take a look at what we're looking at. So the vertex, -1 comma 3, means I'm going to go over to the left 1, and I'm going to go up 3. So my vertex point is right there. My y-intercept is going to be 0 comma 2. So I'm going to be from the origin, I'm just going to go up 2, and there's my y-intercept. My x-intercept is going to be 0.7, so that's going to be basically almost to 1, but not quite. And then my other x-intercept is going to be -2.7, which is just about at 3, but not there, not quite. Now, as you can see, we have some little bit of an arc here, a little bit of a parabola forming. But one thing we want to point out is this idea called the symmetric point. And to refer to that, it's really going to almost be the y-intercept's symmetric point. So if you look at the y-intercept, it's right here. The axis of symmetry, remember, is going to cut the parabola in half so that you can fold it sideways. And that line, that axis of symmetry is always going to occur at the vertex. So if I write that in, I'm going to use this red dotted line to represent that axis of symmetry. That means everything on this side is symmetric with everything on this side. So to answer the axis of symmetry, that's going to be the x equals -1, what I fill in for that. Lastly, the symmetric point. The symmetric point is the one symmetrical to the y-intercept. The y-intercept is located right here, and it is 1 away from the axis of symmetry. Its symmetric point will also be 1 away from the axis of symmetry in the other direction. And so right about there, that's going to be my symmetric point. And I'm going to write that in now as that is -3, comma 2. And so I now have enough points in here that I can go ahead and plot my parabola. So we have to continue the curve on this side. And again, because it's negative in the front, we should have known that it was going to open down, which it does here.